Hello and welcome to this week's Productivity Enhancer. Today we're going to take a look at some simulation functions within SolidWorks Premium. Now if you don't have SolidWorks Premium, I highly recommend that you make the jump up to SolidWorks Premium. There really is a lot of value in jumping up, and these simulation tools are one of those perks. So in order to take a look at these simulation tools, I've created two parts. We've got this bracket here, and you can see that it has some holes on the back with these ribs along the edge providing support. We've also got a different design here with a center rib, and you can see it's virtually the same part, only the support is in the middle of the part. And we're going to see which one is going to be stronger by using these simulation tools in SolidWorks. So let's go back to that other part, and if we go and grab that, you can see both of these parts have American Iron and Steel Institute 1020 steel. And that's important to note because in order to get a true apples to apples comparison, we are going to have the same material for these two parts. Now in SolidWorks Premium, the simulation tab can be found right here. If that simulation tab doesn't show up, then we can go to Tools, down to Add-ins, and SolidWorks Simulation is right here, and you'll just have to put a check in the box. Click OK, and that'll show up right there. We have the Study Advisor, and under there you can see we have a new Study tab. So let's just start a new study. Now our message here says Study stresses, displacements, strains, and factor of safety for components with linear material. You can call this study whatever you'd like. I'm just going to leave it study 1 because this is our first study of the day. And under type we have static. Luckily that's the type of study we want to create. So let's just go ahead and click that. And you can see in our feature manager design tree we do have study 1 show up. And it's important to note our regular feature manager design tree is all here. It's just been kind of condensed to make space for study number 1. And you can also see this study number 1 tab show up right here on the bottom. You can manipulate the size of those windows if you want the study to be a little lower. So in order to run an analysis, first of all, we have to find out what our part is going to be fixed to. So we can go ahead and just right-click on Fixtures and select Fixed Geometry. And this will give us the option to choose a face, edge, or vertex to be the fixture. If you know that you're going to have loads on all of these screw holes, you can select individual screw holes. However, just for time's sake, I'm just going to select this face here, and we'll assume that it's being welded despite the fact that there are screw holes there. We do have some advanced settings that we can manipulate, and that's if we want to get more specific with the geometry that we reference for this fixed face. However, the standard fixed geometry box is going to give us all that we need. So we're going to select this face here, and before I click the green arrow, I just want to show you here symbol settings. You can edit the color of the symbols that show up right here. The arrows are green. If you'd like those to show up as a different color, you can. Just like that. You can also edit the size of the arrows as well. So we'll just leave it like that, accept it, and now you see our fixture number 1 shows up under Fixtures. Next we go to External Loads, and let's apply force. And let's apply force right on this top face right here. Now for some reason, if the direction is different, we can have a selected direction and make it go this way. And by selecting that, you can see the arrows change. But we do not want to have force coming from the side like that. We're just going to use normal, and that way the force will be coming from the top. Let's apply maybe 100 newtons of force. If the distribution of that force is non-uniform, you can enter an equation to show where that force is going to be applied. You can change those equation coefficients down here once you enter in that equation. There's also a way to change those symbol settings under force as well, but we've already explored that, so you know how to use that. We'll just click that, click OK. And for now, that's all we need for this study. So once we right-click on Study, click Run, then that study will run, and we will see where our part is deficient. Once that study is run, you can see under Results, we have Stress 1, the von Mises test. We have a displacement test and a strain test. You can show those, and you can see it shows up right here. Let's just go ahead and hide that. And then even further, what would you like to do? We have a whole list of choices to choose from. We can view the static analysis results, use result viewing tools, etc., etc. And basically what this box does is it points out where the tools are in SolidWorks, so you can do it yourself. So view static analysis, it'll be right up here, the results advisor, use results viewing, etc., etc. All these tools are up here. This just shows you where they are. So we're going to go up to our results advisor, and we can play it and show you the deformation that happens by applying that 100 newtons of force. If we like it, we can say everything looks reasonable, and then we can be finished with the results advisor. So if we take a look at that von Mises test, you can see the spots of stress, and down here you can see our yield strength is 351 million Newton meters squared. So for a simulation like this, we're just going to go ahead and use the von Mises for both of them because it actually gives a pretty accurate yield. So let's go ahead and perform the same test on the other part. So here we have that part with the rib. Let's go ahead and get a better view of it. And let's just start that same exact new study. And this is actually a good point to show you the simulation advisor does show up if you just click study advisor and then it's pinned down. But to start a new study, you do have to go to new study. And again, it's going to be static. So we'll start that study and it shows up here. So first we're going to add a fixture. We need to spin this around and choose this face. That will be the fixed face. We'll click OK. Now we need to apply an external load. And we'll just apply it right here, just like before. Make sure it's 100 newtons. Click OK. And run the study. So let's take a look at our von Mises. So on this one, our yield strength is 351 million Newton meters squared versus, let's go check out the other one. Study number 1 shows us, let's check out that von Mises again, 351 million. So it's pretty close. Let's go ahead and get these side by side. And you can see that it shows an absolutely identical number of 351,571,008 for both of these parts. So in the real world, if we were deciding between these two designs, we'd say, okay, the center rib is just as strong and it requires half the material. So let's go with that. And in reality, that design study took only minutes. So thanks for watching this week's Productivity Enhancer. I hope it's been helpful. Until next time.